Hello, we are starting a new chapter. This is chapter 5, and this is video number 23. So it's chapter 5, section 1. And the beginning of this chapter, well, this whole chapter is all about something called factoring. We're leading up to that in the first couple of sections. But this one specifically is adding, subtracting, and multiplying polynomials. Okay, so there's going to be, I have a few definitions here that you need right at the beginning. So the first thing is that, let's do a degree first. A degree is the highest value of an exponent on a term in a polynomial. Okay, example. If you had 6x to the third minus 4x squared plus 5x minus 7, the highest exponent in that problem is the 3, so the degree here would be a 3. Okay, the degree on the next term is a 2, but the degree is always the highest exponented value in a polynomial. All right, so next you have a monomial. Monomial, there's a bunch of different ways to actually pronounce this. This is a constant, which is just a number, right? Like 10 is a constant, so it's a number. Or the product, which means multiplying, of a constant and one or more variables. Oops, variables. Okay, so examples here. The number 10 would be a monomial. 15x squared y would be a monomial because here is a constant and these are multiplied by x squared y. So this would be a monomial. Anything that is one term linked together, x or negative x, is a monomial. The coefficient here would be -1, right? That you don't really see. We don't write it. And then the x. So let's talk about degrees on these. What would be the degree of the 15x squared y? That's a little bit of a trick question, to be honest with you. So this term has two variables. So if you have two variables, the degree is the sum of all exponents in a term. That's how if you have multiple terms, so the y has a 1, so this would have a degree of a 3 because the x is squared, the y is 1, and you sum, which means you add all of the exponents in a term. So the degree of the 15x squared y would be 3. How about the degree of the -1x? Well, if you don't see an exponent on a term, that's automatically a 1, and so the degree of that guy would be a 1. And what about the 10 here? Well, that doesn't have an x at all. So this is really, any constant is really a variable with a 0 degree because anything raised to a 0 degree is 1. So this is really 10 times 1, which is just 10, making the degree 0. So those are kind of some strange circumstances, but they're good to cover and talk about when we do something like this. Also, the word coefficient, right? coefficient here, the 10 would be the coefficient. It's the number on the variable term. The 15 would be the coefficient in the second, the black box. And in the red box, the -1 would be the coefficient. Even if it looked like this, right? That still has a -1 for a coefficient. All right, let's keep going with some definitions here. A binomial is exactly what it sounds like. Let me switch my color here, get a little bit more space. A binomial is a polynomial with exactly two terms. Okay, and as we move forward, you're going to see things with a lot of binomials and trinomials, and it's very handy if you can reference those using mathematical language. Trinomial is a polynomial with three terms. And the word polynomial itself is really used for anything with two or more terms, but often it is used for when there are four or more terms. Okay, but technically it can be used when there are two or more. We just try to use binomial and trinomial to separate them out specifically from anything larger. All right. And then we've talked about like terms in the past, but just a revisit of that. Remember that like terms must have exactly, and I'm going to put must and exactly underline, the same variable and exponent combination. Same variable and exponent combination in order to add or subtract them. So for example, if I have 3x squared y plus 7x squared y, they both have an x squared and a y attached to them. And remember, when you add, you're just adding your coefficients together and keeping your variable combination exactly the same, right? So 7x plus x, there's an invisible 1 on here on that x, so that would be an 8x. You don't change your x or your variable or your exponents, you just add the coefficients together. That's when you add and subtract, right? When you multiply, all those rules change and go out the window. And this video has addition, subtraction, and multiplication in it. Just as a review, you should be fairly fluent with this, but Varsity kind of ups it a notch and really throws a lot of binomials in there and makes you multiply by a lot of negatives and things. All right, the first couple questions that you're going to see in Varsity give you an expression, 3x to the fourth plus 6x squared minus 5. And then it asks you three questions. It says, what is the degree? What is the leading coefficient? And what type of polynomial is it? And I believe this one's a drop-down box, and it'll say monomial, binomial, trinomial, or polynomial. And so if you have one term, two terms, three terms, or four or more terms, you would pick the appropriate type of polynomial. The degree and the leading coefficient you have to fill in, and they always come together. So the degree, remember, comes from the highest exponent. And don't assume that they're going to put these in order. They may not, right? This might look like 6x squared minus 5 plus 3x to the fourth. Either way, this term in both of these has the highest exponent, right? And so the degree here would be 4. The leading coefficient always is on that term with the highest degree. So the leading coefficient here is a 3. And because there are 1, 2, 3 terms in this, this would be a trinomial. Okay? So that's all you have to do if you see something like that. They do throw a tricky one in there and just say, hey, here's this constant 12. What is the degree, leading coefficient, and the type of polynomial? Well, we talked about this a little bit on the last screen. Remember, if you see just a constant, this is really x to the 0. And so the degree here would be 0. The leading coefficient would be the constant. And because it's a single term, this would be a monomial. Okay, so there's a couple questions like that that you're going to have to answer. And then you're going to have to just simplify by combining like terms. So let me give you an example of one that like you might have only seen 2 binomials before, but these get a little crazy in varsity. So we have simplify. 2y cubed minus 4y squared minus 5y plus 2 plus 2y squared plus 1 minus 3y cubed plus 3. Now, just a couple things here. If you have a plus sign in front of a set of parentheses and no coefficient here, these parentheses are not necessary at all, right? So when I rewrite this, I can just drop those parentheses off. And the same thing happens on this leading term here. This is really a plus in front of here because there's no sign. So these parentheses are completely unnecessary. And they're just thrown in here to see if you realize that they're unnecessary, right? And then if you have a minus sign in front of a set of parentheses, remember that that's actually a -1, and you need to distribute that negative to both or anything inside the parentheses. You could have 15 terms in a set of parentheses. Make sure you distribute until the last term before the closed parentheses. So I'm going to distribute and bring these down. So it's going to be a minus 5y minus 2. We already brought down the next binomial, plus 2y squared plus 1. And then there's another minus here at the end. So put your 1 in there and distribute. So I have a minus 3y cubed minus 3. The negative or minus signs are super important. And generally, it's where people kind of lose their minds and make mistakes. So just be careful. Then combine any like terms. So I'm going to start with my highest degree, my highest exponent. And I have a 2y cubed, any other y cubes, and a negative 3y cubed. 2 minus 3 is -1. So this is technically a -1 y cubed. That uses both of those terms. I'll change colors here for each one. Then I have a negative 4y squared and a plus 2y squared. So that's a plus, nope, I'm sorry. That's a minus 2y squared. And that gets rid of those two terms. Then I have a standalone 5y. There's no other y term here, so minus 5y. And then I have a minus 2 plus a 1 and a minus 3. So minus 2 plus a 1 minus 3. This is -1 minus 3 is minus 4. So this is going to be a minus 4. And then when you have no similar exponent terms, no like terms to add together, as you don't in this answer right here, then you're ready to go put your answer in varsity, except you would not want to put this 1 in here, right? So this would be written as -y cubed minus 2y squared minus 5y minus 4. And that would be your answer to that problem. Okay? What if you have multiple sets of parentheses? So here's an example where you have a negative 4a minus b minus a square bracket, and inside the square bracket you have parentheses 5a minus 5b minus 3a minus 4b. Well, remember, a rule of thumb is always to work from the innermost grouping symbol I don't want to say parentheses because the brackets are not parentheses, but they're a type of grouping symbol. Work from the innermost grouping symbol to the outermost. And you can eliminate or change them as you go. And grouping symbols are parentheses, brackets, braces. A square root sign can be a grouping symbol because you do everything under the root. A fraction bar can be a grouping symbol. So there's a number of them. The common ones that we're going to be working with would be these two right here. Okay, so looking at the problem up above, you have this big set of brackets right there. I would completely ignore this minus sign and do what it says inside the brackets. So I'm just going to bring down the front part. So I have a minus 4a minus b minus, and I'm going to keep my bracket. And here I'm going to just distribute this negative. Remember, that's a -1. So I have 5a minus 5b minus 3a plus 4b. And these brackets could now change to parentheses if you want. In the next step, I'm going to do a couple of things. I'm going to distribute the negative, and then I'm going to combine like terms inside here. So I have a -4a plus a b minus 5a minus 3a is 2a. -5b plus 4b is -1b. And now I can distribute my negative here. So I have -4a plus b minus 2a plus a b. And now I'm going to combine like terms again. So I have the -4a minus 2a is minus 6a plus a b plus a b. Remember, there's an indivisible 1 in front of those. Indivisible? No, invisible. So that's a plus 2b. You no longer have any like terms, and that's how you know when you're done. So you are done when there are no longer any like terms. Okay, and that's the end of essentially 5.1. So you'd be ready to go do your varsity after that. And if you want to pause this and do those notes and go do varsity, you can. And then come on back and we'll do some multiplication. All right, so remember when you multiply exponents, well, multiply bases, I guess that's really the more correct way to put that. So when you multiply terms, we'll use that as when you multiply terms with exponents, you end up adding the exponents together. Okay, for example, if you have 3x squared times 4x to the third, you multiply your coefficients, but you add your exponents. So we'd have 12x to the fifth, right? This is something you should have known from Algebra 1 coming into my room. So I'm not going to take the time, any more time to go over that. I have 1, 2, 3, 4, 5 examples here for you, and then you'll be done with this video. So this is all multiplying polynomials. First one is just distribution. Okay, so you're just going to distribute what's out front to each and every term in the parentheses. Use your sign rules. Remember that a positive times a negative is always a negative. Positive times a positive is always a positive. Negative times a negative is also always a positive. And these ones, doesn't matter what order. It could be a negative times a positive. If the signs are different, it's negative. If they're the same, it's positive. So moving forward here. Negative 4x squared, or 4x times 4x squared. We get 4 times 4 is 16. We have a negative times a positive is a negative. And an x to the first times x squared is x cubed. So that's what your first term would be. Then I have negative 4x times negative 5x. Well, negative times a negative is a positive. 4 times 5 is 20. X times x is x to the second because they both have x to the first on them. And then the next term, negative 4x times 3. Well, here I'm just multiplying my coefficients. So a negative times a positive is a negative 12x. Again, here you're done when all of your terms don't have any like terms. And our degrees or our exponential terms are 3, 2, 1. Nothing to add together. And so that would be done. So this is distributing. Okay. The next example is an example of, you may have learned it as foiling back in your Algebra 1 class. Typically, it's taught with two binomials, but it doesn't have to be binomials. These could be trinomials. They could be giant polynomials. It's the idea of distributing every term, right? And so what I actually like to do is ignore, I'm going to make this little box. This might take a second here, but I'm going to make a box and I'm going to cover up the 5. And in that 5, that box, we're going to make it, we'll just make it an obvious black box. Okay, so all you're doing here is double distribution. You're taking the first number in the first set and you're distributing to both numbers in the second set. Okay, so 4a times 5a is 20a squared. And 4a times negative 3 is negative 12a. Well, then what I want you to do, and you could put your finger over these when you do them, you don't have to have a physical box, but then we're going to move the box. Make sure you include the sign with the second number. So if that's a plus or a minus, whichever one it is, then we're going to distribute that one to both terms in the second set. So 5 times 5a is 25a. And 5 times negative 3 is negative 15. And then you're going to combine like terms if you possibly can. Well, we can here because these two are similar. So we're just going to drop down the ones that don't have like terms. Negative 12 plus 25 is a positive 13a. And this guy, the negative 15, doesn't have a like term. And so that's a quick review of foiling. Like I said, I like to just think of it as double distribution. That's what you're really doing. Okay, so I'm going to use that in the next few problems going forward for those of you that struggle to actually do the distribution. All right, the next problem I just want you aware is going to look like, it's going to say multiply. And then it's going to say 3a minus b quantity squared. Well, remember when you have an exponent, it means that there's this many of the base. So this is really 3a minus b times 3a minus b, right? And you need to make sure you write this twice and then FOIL. If you don't, if you just square what's inside of here and square this, which would give you 9a squared plus b squared, you'll see how this is going to actually give you the incorrect answer. It'll be close, but not quite right. So I'm going to draw that little box again. And I'm going to put it over the plus a b. Fill that box in. Fill color. All right, we're just going to drag him over here just a little bit. Okay, so I'm going to take my 3a and multiply by those two things. So that gives me 3a times 3a is 9a squared. 3a times negative b is negative 3ab. And just put your exponents in alphabetical order if you have multiple exponents, okay? Then we're going to move the box. Make sure you take the negative sign with the b. So now I am multiplying negative b times 3a and then negative b times negative b. So negative b times 3a is another minus 3ab. Don't put ba, put them in alphabetical order. And then negative b times negative b is a positive b squared. Now I'm going to combine any like terms, which you see right in the middle. So I have 9a squared minus 6ab. Remember, I'm adding my coefficients, plus b squared. And this would be the way you'd want to see this, with the two squared terms on the end and the combo of the two in the middle. Okay? That's actually a pretty common way to look at that. All right, so the thing here is making sure that you write twice and then FOIL. So if, here we missed the middle term, which is the problem. All right, another example with just a little bigger multiplication. You have a plus 4 times a squared minus 4a plus 16. The directions will just say multiply. So if you could just use your finger and cover up the plus 4, and this plus 4 in the parentheses, we're going to just multiply the a by all three things inside these parentheses. So a times a squared is a cubed. A times negative 4a is negative 4a squared. And then 4 times 16 is 64. Okay, and now we're going to take the 4 and multiply. And if you want, you could line these up horizontally, vertically, up and down, when they match up like terms. So I'm going to go 4 times a squared is 4a squared. So I'm going to put that underneath the a squared term that I had before. And you don't have to do this, but for me, I kind of like it. And then I'm going to go 4 times negative 4a is a negative 16a. Well, that wasn't in this problem at all. So I'm going to go negative 16a. And then I feel like something actually went wrong. I did do something wrong. Oh, good Lord. Hold on. We're going to go backwards because I don't want some of you may have caught it as it happened. All right. So we're back here. A times a squared. The first one is a cubed. And then a times 4a is negative 4a squared. Then I do a times 16. I did not do that right last time. I don't know if any of you caught it. That's a 16a. All right. Now let's go back and multiply this guy. Again, 4 times a squared is a positive 4a squared. 4 times negative 4a, the middle term here, is a negative 16a. And then I have 4 times 16, which is a 64 plus 64. And then you can draw a line under these and add down. Right? Your other option is just to write these all next to each other and just get this big giant string of numbers. So whichever way you want. So these will cancel. And look, these will cancel too, leaving us just a cubed plus 64. Okay, so that's all that's left. All right, and then the last one just has 3 sets of parentheses with some other information happening. So I just want to cover it to make sure you know the process to go about it. So multiply 2 times x minus 3 times x minus 2 times x plus 2. Well, I want you to do this last. Okay, make that the last thing you do. So what we're going to do here is we're going to FOIL here first. So we're going to do the x minus 3 times x minus 2. All right, well, that's going to give us x times x is x squared. X times negative 2 is negative 2x. This one's a negative 3x, and then a plus 6. And I'm going to add down. So I have x squared plus 5. Geez. Sorry, that's a minus 5. X squared minus 5x plus 6. That's going to go into a set of grouping symbols. So a set of parentheses. Then bring this guy that you didn't use down, and you're going to multiply again. So now I'm going to take my x squared and multiply by x and 2. So that's x cubed plus 2x squared. Then I'm going to take the negative 5x times both of those. So that's going to give me a negative 5x squared minus 10x. And then I'm going to take the 6 and multiply by the x and the 2. So that's going to give me a plus 6x plus 12. And then I'm going to add the blue, the green, and the purple. So I have x cubed, that's gone, minus 3x squared, those are gone, minus 4x, those are gone, plus 12, no like terms. And now, last but not least, I'm going to drop this 2 down and multiply by everything, or distribute it to everything in the parentheses. So this is going to give me 2x cubed minus 6x squared minus 8x plus 24. And that's going to be my answer. Okay. All right. That wraps up this whole video. That now gets you ready to do 5-1 and 5-2. Remember that 5-1 is adding and subtracting, and 5.2 is multiplying. All right. And there might be some additional assignments in there. I don't know, besides varsity. There may or may not. All right. So toodaloo for now.